The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show. I see you're taking a look at one of our Xbox One accessibility controllers.
Yeah, you and Felix are always making these in the background, so I figured I would pick one up and see what it's all about.
Yeah, well, I've been building these for about 10 years now, and in the last year, Felix has actually taken over the operation as a side job. Yeah, the basic idea is if someone doesn't have use of both hands, these controllers move all the controls to one side or the other, allowing them to play. Yep,
cool.
Just like that.
And make these righty and lefty, right?
Yep, there's a selector on the website. The thing is, we've never been able to make a PlayStation model. Yeah, it's not a conspiracy theory. I don't hate Sony PlayStation. I actually have a PlayStation 4. The problem is, PlayStation uses a silk screen printed circuit on its controllers, and you can't solder to plastic. It's very hard to, it's impossible to do. And what connections there are basically hidden under dark solder mask, so you can't see them, and the connections are all very small. Whereas the Xbox 360 and the Xbox One have nice standard circuit boards. And this one's even easier because they have connectors between the halves, which means you can just solder to those points. There's the signals. Very easy to do.
So you recently found a third-party PlayStation controller, didn't you?
Yes, there's actually very few third-party controllers this generation. It's not like the old days where you could buy them for $10 at Walmart. But there is something called the Hori FPS Pro, and it's a third-party PlayStation 3, PlayStation 4 controller. There's a selector switch on it, and it has the touchpad that the PlayStation 4 has.
Okay.
So it could actually be used for PlayStation 3 and PlayStation 4.
Oh, that's cool.
So what I want to do in today's episode is obtain one of those, take it apart.
Hopefully find one of these.
Yes. And if there's a circuit board inside, that means we can finally modify it for single-handed use. So if we find a circuit board, then what we will do is we will design a controller around it. We'll create the 3D printed parts for the new dpad, the secondary trigger, the analog stick on the bottom, and hopefully finally get a PlayStation 4 accessibility controller designed.
You'll have some really happy gamers if you can do that.
Yeah, there's 40 million PlayStation 4 owners out there? It's like the fastest selling console ever. And there's a lot more of them than Xbox Ones. I mean, there are probably people that buy an Xbox One just because it's the only one that has a disability controller. I'm sure that's happened. And nothing against Xbox One, but there should be variety. So yeah, PlayStation 4 accessibility controller. Fingers crossed. Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
I started by examining the Hori FPS Pro. One thing that I noticed was that the shoulder buttons don't have nearly as much throw or movement as I would like them to. Maybe we can improve that in our design. When I cracked open the unit, I found exactly what I was looking for. Circuit boards with well-labeled test points. This is perfect for our purposes. Let's start designing. So what Felix has been doing is he's been putting together some tests. We want to do this as close as possible to the Xbox One version. So the first thing we need to do is move the D-pad. Now on the Xbox, we have the D-pad connected down here with a little 3D printed part. We want to do the same for the PlayStation. So you have the shoulder buttons here and the D-pad here.
There's the shoulder and the...
Oh, all right. So in this case, it'd be R1 and R3 right there. Because on the Xbox, we put those here, right?
Yes.
But these, the parts that go into your palms, they feel a little stubbier on this. So we don't have much room. But I like this because I can just bring the joint of my thumb right down and hit it.
Yeah.
And then this is a little hard to reach, and you have it at like 45 degrees, like an X. We should probably have it maybe not quite straight up and down, but maybe like 22.5 degrees. Sure. That way it's obvious which one's up, because there might be like, oh, is that up? Is that up? And they might not know. What I think we could probably do is I could work on getting this curvature into the computer so we can make a part that fits. And the D-pad on the cap, that would be the same as the Xbox version.
Yeah.
The base, which it sits on and has these buttons, there could be a special base for the PlayStation 4 version. And then all we have to do is design it once, and then we can mirror it in Mesh Lab and make one for over here as well for right-handed use. Okay, so here are the parts that I'm designing for the face buttons for this PlayStation controller. So we have the cap here. This will fit down over the hole in the shell as opposed to the ghost in the shell. And the D-pad fits right there. So there's where the D-pad is on the original controller. And then here's how my cap fits into it. So this X shape here will actually fit into the existing plastic. And below that, we have the buttons. So I've put the buttons closer to the thumb. I made them a little lower so you can feel the difference between the buttons. And one's concave and the other one's convex. Then below that, we have a little flat portion so the buttons don't fall out. So this gap here, this represents the thickness of the existing controller plastic, which is 0.1 inch. It's one of those, another one of those things that was probably designed in millimeters, but has a lot of imperial measurements in it. And then finally, we have the switch base, and that's going to hold the tack switches in place right under the buttons. Tack switch is about, well, it's exactly 0.195 inches tall. So I have a gap of 0.2 inches, so there's a little bit of slop. Because if you make everything fit really precisely, it either won't work or the buttons will be pressed always, or you won't have any room to push the buttons. They won't, I mean, they'll fit, but they won't have any wiggle room. So yeah, we're going to print this out, glue it together, and see how it works with a controller.
So man, that's a really nice controller button.
Oh, thanks.
Quad button.
So there's 3 parts to it. There's a cap. The cap will glue on here. Then there's buttons that are all one piece. And the ones closer to your thumb are lower, so the curvature of your thumb can reach them better. So these are concave and these are convex. So they feel different too. You don't have to look at them. And then there's a bottom portion here that has the tack switches. Now we just glued them in place just to test, but this is basically what it'll be like inside the controller. So I was thinking we could break this apart and see if we can fit it in there.
Yeah, good idea.
So that's what the 3 pieces look like. So inside the controller, we have some, I don't know, moldings. So I designed the 3D printed parts to intersect with the moldings. So this is the cap, and it will fit in between the cross of the D-pad like that. So we would glue that in place. Then you would drop in the buttons. I'm just holding it in place right now. And see, the buttons should flank the molded pieces. And then this will have a screw in it actually, so it'll screw into the cap instead of being glued. And then this should fit around the 4 plastic corners there. But I think it'll all work out. So what I'm going to do next is I'm going to add holes in this piece of plastic for the tack switches to attach through. And then we don't have to buy a PCB because plastic is a lot cheaper than a PCB.
So Mr. Heckendorn has designed a new iteration for the button holder and the cover that goes on the top. There's these fancy little chevron standoffs that mate with the chevron standoffs that are in the housing itself. He made them a little shorter so that they would fit in there. Before, the first one, he just glued these on here, but he made some holes there so they fit in there. The buttons fit in here really nice. That's pretty cool. And he put a hole so a size 4 screw can fit in there. I had to trim it down a little bit so that when it screws onto here, it doesn't go through the faceplate. So put this bottom piece right in there like that. And the top will fit on here. Let's see here. I get the screw. Eventually we'll take the top piece and glue it on to the face and then attach the bottom with a screw, like so. I'm tightening the screw. There we go. There's the top piece with the bottom screwed on and the buttons sandwiched in between. That's gonna be good action for the buttons. Now right now, Mr. Heckendorn is doing some fancy work figuring out what the curvature is for this, the bottom part of the controller there, and he is designing a 3D model for this part right here.
Okay, I want to figure out the curve on the bottom of this controller. So what I did was I took a photo of it with a ruler across the top. So the ruler is on the analog stick, so it's not going to be perfectly accurate, but it should be close enough. What I've done here is I've drawn some guidelines in Photoshop, and I've rotated the image to make the ruler as horizontal as possible. And the ruler itself is lined up to the bottom of this touchpad. So the ruler should be straight to the controller. So if we can make the ruler straight on the screen, we should have the best drawing that we can get. So I'm going to put the rotation point here, and I'm going to just rotate this just a little bit more. That looks pretty good. I'm going to bring this down here. That looks about as close as we're going to get. Okay, so this was a photo taken with my cell phone. So unlike something in the scanner, this is not at actual size. Again, that's why we have the ruler. So I can go here. I'm going to trim off the edges of the ruler just so we have a solid inch perimeter on each side. So we have 1, 2, 3, 4, 5, 6, 7 inches. So what we can do now is we can trim the image like that. And now I can resize the image Let's see, so let's not resample it. So we keep all our pixels. Width, we want to constrain it, so we want to make sure, oh, it looks like it's already constrained. So 7, okay. So allegedly, that is the shape. So let's save this. Let's go into Adobe Illustrator. So this will be placed into Illustrator at its actual size. So if I draw a square, it will be 7 inches wide. The reason I did this is because now I can draw a curve on the screen that will hopefully match the curve of the controller. That's pretty close. I want to make a 3D design of that foam core thing that Felix is drawing. So really all we need is this area. As long as this is close enough, it should work. I realize there's a problem with this 4-button pad that we made. So this part goes in fine. And then the 4 buttons, you know, they fit in there just fine. So again, this is basically fitting where the D-pad was. The problem is the switch matrix thing that we put behind it. Well, it's not really a matrix, it's more of a grid. This fits in nicely, you know, it fits in nice and tight, and then you put a screw in, but this isn't gonna fit when we put the circuit board back in. The circuit board won't be able to go flush and flat like it's supposed to. It's gonna be a little crooked. You can see how the disc goes up against the PCB. It looks okay, but then if you look at it from this side, see, it's pushing it up because these switches should be lower. They should be closer to those grooves. So that's not good, but there is a possible solution. We need smaller, shorter tack switches. We could use this little guy that we got from Macrofab. We use this right now for the D-pad on the Xbox One controller, but it uses surface mount switches, which don't take as much space. So if we put those in place right there, then its profile is lower and it should fit. I mean, we'd still have to make a 3D print behind it, but I'm just testing. Now, I prefer not to use these because they cost like, I don't know, $2.60 each, and we only have 100 of them, which means we'll run out of them pretty quickly. But if this is the only way to do it right, then I will use them, because ultimately it's about making it work, not necessarily making it as easy or cheap as possible. That part comes later.
So while Ben's over there working on a few other things, I've been figuring out a placement strategy for our analog stick here. I have a couple of iterations that I've made, and print just finished. I'll go pull that off in a bit. Another thing I'm working on is the analog, or the trigger. For the Xbox, we have this mechanism here, which we use a Hall effect sensor, but the PlayStation, it uses those domes. So we might put that in here instead. We have a trigger here, a spacer that fits in there, a spring that fits down in here. So here's how our trigger is configured with the Xbox. Right now we just have that glued on there. We'll figure out something a little bit different for the PlayStation. The analog stick is going to fit right down in here. I made a couple of iterations for a cap that could hold it in place, because for the Xbox we just glue it on there with hot glue. But we're looking for something a little bit different in this one. First I made this cap. This is just to see if I can get it to fit right. But the issue with this is it goes a little too high, and then we're not going to have any action with the analog cap. So take a look at this piece that I just printed. I'm just going to clean this up a little bit. I got to peel it off of this raft. I had a little bit of trouble getting this to stick to the bed, so I added a raft to it to get it to stay on there. So instead of having it cover the whole top, we just have it go over. May have to make a little bit more of a modification, or that actually might fit okay. Just have to extend it down. Yeah, let's see how this cap works on here. Well, this cap will work as long as this housing is lower. So what I'll do is I'll bring this housing further down and perhaps make some sort of a contour here so that it fits snugly, or has a nice place to sit on or to attach to the controller here, and it'll sit somewhat like this. I'm gonna go ahead and work on that some more. So Ben made this really awesome mount for the analog, and I have an adapter that the analog stick fits into, so that we can either have this on the left or the right. And then with this adapter that I made, we can set it on there and get the angle right. So if it's for the left hand, we'll put it like this, and if it's for the right hand, we can screw it down the other way. And I've put some little size 4 screw holes on here so that we can fasten it to the plate that he made. I'll solder these leads together and attach some wires and feed the wires through this hole there. And that's about it.
So I want to put this flat ribbon cable here in such a way that I can reach everything. So I'm going to use a little bit of hot glue. So the order in which I'm going to wire these is just the order that is the easiest to connect it. That keeps everything as flat as possible so it'll fit. So the reason we made this little D-pad here is because we needed a replacement for the Xbox 360 version of the D-pad. We were using a 4-way tack switch, but it was getting damaged a lot by the users. So the idea behind this was to make something that was tougher. And we tried manually putting buttons in, but it was really hard to wire them. So what we did was we had this PCB made by Macrofab down in Texas. And I don't know, well, actually the cost of it isn't that bad. This is only slightly more expensive than a 4-way tack switch joystick, but it'll be a lot tougher because instead of getting tilted, it just gets pressed upon. And the tack switches that we use are a little stiffer than I would like, but that also means that they'll be a little tougher. So I'm just gonna get these connections wired up, and then we'll figure out how to fit it into the controller. I probably should have wired those before I put this PCB into the 3D printed part. It would have been a little easier. Oh well. Hindsight is 20/20. So now we can insert this where it goes. Okay, something else I might want to do is put a little groove here on the plastic so the ribbon cable is not pinched when we assemble the unit. So I'm just going to mark it with my X-Acto knife and hit it with the Dremel. Let's make sure everything still goes together. Still clicks. That's good. So I've got this ribbon cable here with the crappy glue on it. I think what we could do is probably replace this entirely. So just for now, I'm gonna get rid of this ribbon cable. It's all well labeled, so we know exactly what it does. You can kind of tell the quality of a product by the type of ribbon cable and glue it has inside of it. If it's a piece of gray ribbon cable with hot glue around it, it's usually like a lesser quality thing. But in this case, you know, this is what we need. So I'm okay with it. And you know, it makes it easier because we have a easy place to attach our own cables. Okay, so I just got rid of that ribbon cable just to clean it up for now. Now the D-pad contacts are right there, and the other ones are over here. And it's weird how they're labeled. They're right here. It says button up, button left, button right, and button down. Yeah, but actually that matches for us. Who cares what the symbol on the button is, as long as we know which button position it's in. It's nice that there's little test points there because we can solder right to them and put our wires on it. So test points on a circuit, after they make the circuit, they'll set it onto a bed of nails, which is a board with a bunch of nails in it or pogo pins, and they'll touch against the contacts, and that way they can test all the functions of the controller without actually playing it. They put it on a test bed. That's why you see extra pads for everything. Most PCBs do have those pads. It's just that in this case, they're very well labeled, which is nice. So we're just gonna think about how we're gonna move this around. I'm gonna probably put it like right there. And I'm not gonna connect this yet. I'm just gonna snip it off so we have enough length, because I want to put the rest of the controller together first. I don't want this to be in the way. See, we'll probably have to snake this around or between these ribbon cables for the analog sticks. Yeah, I think that's a pretty solid way to go with that. There's two switches on the bottom of this controller. One's a turbo switch. The other one selects PlayStation 4 or PlayStation 3. Turbo switch I don't really care about. Maybe the buyers would, but I think it's cheating. I am an honest game player. I go online and I get my butt kicked honestly. So what I'm gonna do is I'm gonna remove both of these switches so we have room for the wires coming from the D-pad section. However, the PlayStation 4, PlayStation 3 selector switch will move that to like the bottom of the unit. That way, you know, whichever system people have, they can easily switch it. Like maybe they don't have a PlayStation 4, they only have a PlayStation 3, and then Santa brings them a PlayStation 4, and they can plug it right in without missing a beat. Now how much would you pay? Once I get these switches removed, I can start putting the front half of this unit back together. That is, if I can get the switches removed. I need to connect the buttons that we added on to the original PCB. I'm going to start with the replacement 4 face buttons. They have test points in the back here, and they're labeled up, down, left, right, which is great because I don't care what the symbols are. So I'm just going to bring this over here, and we should be able to reach them. So I wrote down the pin out on my Post-it note, so that should match. So I'm just going to get this wire in position. I want to make sure that there's still room for the ribbon cable to attach later when we attach the analog sticks back. That should be good. So I'll get it as close as I can. Then I'll just give it a little bit of hot glue. Make sure the hot glue doesn't go anywhere that the case will go. Then I'll get these wired up. This is the D-pad. The D-pad test points are actually right here, which is really handy. The R3 connection, I actually can probably go right over here for that, and that just leaves the R1 connection, which will go over here. So again, this circuit board is actually quite handy. Everything is like right on this surface, which is great. I mean, why not leave test pads everywhere? Unlike the PlayStation 4 controller, where there's dark silk screen over everything and you can't tell what's going on. Okay, quick overview. These are the 4 face buttons wired up to the test points. D-pad hooked up to the test points. And then R3 and R1 hooked up here and over here. Then I put a 10K resistor here to replace the one that we don't have installed for the R1 and R2 board. We don't have the rear trigger put on yet. We'll get to that soon, but this should work. And then when we actually attach that board, we'll attach it here and here. Or I guess we could use that one as well. But yeah, I'm gonna test this on the computer and see if all the buttons work. Okay, X, X, good. Square, square, good. Triangle, triangle, good. Circle, circle, good. R3, good. R1, good. Try the D-pad, up, down, left, right. Cool, that all checks out. So all we have left is to add Felix's analog stick and then create a trigger assembly. Now there's a little circuit board here. We can see it here for the L1. And the circuit board's actually the same on the left and the right. And it has the carbon pads on it, which have 10K resistance across them. So that's what we're replacing by adding the resistor down here. So what I think I want to do is I'll take this entire circuit board and move it to the back of the controller. That way we can just have 2 wires going to it for the R2 button. And then we need to design a trigger that compresses this silicon pad, and I want to do it in a better way than this controller did, because this controller, you know, the buttons don't have very much throw to them, whereas a real PlayStation 4 controller, the secondary buttons, you know, they're meant to be analog, like they have a little bit of throw to them. So what I think we could do is we could make like an analog stick that, instead of compressing like from a pivot point here, it can compress here, so it immediately presses it, and then the further you press the trigger, it acts like a lever and adds more compression to this, spreading out the silicon dome, decreasing the resistance, and being a further pulled trigger. So yeah, that will be the next step, is figuring out the trigger. Okay, we've got Felix's controller hooked up here. I'm just trying to see which one's which. Looks like the first wire is the Y measurement. So I'm gonna bring this here. Let's figure out what the reasonable minimal distance is. Probably kind of like that. Now, there's no rumble motors in this, so it saves us a little space. We can use that to pack in some wires. Still don't want to make the wires any longer than they need to be. As long as you can take the unit apart and you have enough room to open it up, that's all I care about. I'm going to attach the trigger shell to the back of the controller. First, I'm just going to see where it feels good. All right, so I'm going to use my middle finger for this. So here's something that might be a challenge. This trigger is kind of large, and if I make it like this, if I put it right here, it's going to kind of take up a lot of space. It might make it harder to hold the controller. Well, we'll give it a shot and see what happens. So I'm just going to take this blank one that I have and drill some reference holes. Hopefully I'm not destroying anything inside of it. Oh, I think it'll be fine. Okay, so it's got good analog feel. I didn't really need a spring, but I put a spring in anyway because we have springs. There's one more thing we need to add though. We need to add the PlayStation 3 4 switch. So we just need to find a place to put a toggle switch or something that you won't hit with your hands that can be changed, probably on the back of the unit someplace here. Or we could remove this target button that does nothing that I know of and put the switch there. Okay, we're gonna test this controller with everyone's favorite game, No Man's Sky, which I've actually never played. We have to hold the button to do this? Am I dead?
What?
Your ship has crashed. Okay. Oh, I'm like on Christmas Planet. This is Halloween, this is Halloween.
Why am I hearing GLaDOS?
It must be my computer. This is the PlayStation 4 Pro, it doesn't look that much better.
There's an island in the sky. Check out these amazing graphics.
How is that even pronounced? Sub-Zero Swampland, that's not good.
Acnumalats.
Admiral Akbar. Let's see if I can look around. Whoa! Oh, a creature. I'm gonna take a look at it. Hey, little guy.
I'm waiting for him to go bare teeth at you and just dive at you. Oh, he looks so. Oh, wait, no.
Oh, he doesn't like me. That's usually how cats react to me. Oh, I can.
There's a tree. Whoa! Are you mining carbon from that tree?
Yes.
Interesting.
Yeah.
It's laser.
I'm an American. I'm gonna take all this planet's resources. It's a new world. You want to try it?
I want to see if I can do the Well, I don't know how to play this game at all, so.
It's just a first-person
Actually,
game.
I can't. Oh god, I'm already terrible at FPSs because I can't do the like look and move separately. Like I'm bad when I have two hands.
Do you want to try a 2-player game instead?
Sure.
Oh, there we go.
Oh. Hey.
Oh, I can punch. Sweet.
Woo! I freed a guy. I hope I can't hurt you, cause. Oh, they're like.
Take that, Karen.
Oh.
Oh, okay. Okay.
You have to push down and.
That might be tricky with this controller. Oh, there we
Yeah,
go. Got him. What is that thing? Is
Bad
it a
guy?
Is it like a rutabaga?
Wait, I did.
Oh, sorry.
Over here. All right, I think there was a
Whoa!
guy.
Ah! Help me!
All right, yeah, we saved the guy.
He's probably like,
Oh, they're wearing like
"Kill
little
me."
like striped jackets, so they look like prisoners. That's cute.
That's all the time we have for today.
So we've done controllers. What other electronics could you see being modified for accessibility? Let us know on the Element 14 community on element14.com/TBHS.
You can also go there to read about other upcoming episodes, builds, and special events. We'll see you next time. Harrison Ford is really mean to random people.
Did you say something about there being the spirit of a warhorse in every man?
That's exactly what I said, actually. I'm a cat. Here's where the not fun begins.
Snoopy Wonder?
I should tell Ryan that the space movie is like, we've changed it. It's all puppets now. Why do I keep turning that off? I'm a fool. I'm a cat. Oh, and it erased all my templates out of my templates file. Oh, this is great. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.